Good afternoon. Okay, so today let's continue with our discussion on class inheritance. Then we're going to move on to a review of pointers, if we have time. And then after that, we will go to a topic called polymorphism. And polymorphism unlocks a really nice power that is very heavily utilized in a lot of applications in C++. Okay, so I introduced this topic last time, which was, okay, I'm going to create a class called point2d. It's one of my favorite classes to work with. And this scenario is, all right, I've spent all of this time. I've made this beautiful point2d class. It works really well. I don't want anyone to mess with it. I don't want anyone to even think about making any changes to it. Okay? But something comes up and someone says, well, wait a minute. We need the point2d class. We need a color associated with each point. And the question goes, well, if I rewrite or modify all the code that I've already written, I might mess something up and spend hours and days or months trying to fix it later on. Isn't there just a way to utilize the code I've already written and just extend it in a way where I don't even have the potential to mess up what was already written before? And that's the idea. You don't even want to give people the ability to mess up your code. That's an important, think about that for a second. Imagine if you had the ability to actually modify the std vector, the standard library's vector class. Would you want to do that? Probably not, because probably you would do something that would seriously mess it up. And then once you've done something that messes stuff up, you'd have no idea how to fix it. Okay? It's the same principle here, except now somebody else is writing this class, and you want to use it, you want to make the full use of it, but you don't want to even have the possibility of changing it. The other advantage, too, is that maybe you want a point2d with a color property right now. Maybe somebody else just wants a point2d without a color property. And let's say you're working with millions of points. It does not make sense to carry around extra variables if you don't need to. In particular, maybe somebody else is going to have a point2d with a different object or some other way to use it. Okay, so there is a definite need to have access to a standalone point2d class, but then you also want to be able to extend it without too much effort. Okay, so like I said, we want to add a string property to it, a color variable. Here's how we would do it. So what we would do is class color point2d, and then we'd write colon public. Public is very important. Okay, public point2d. Okay? Now, the colon public point2d tells the compiler that this new class is derived from or inherits from the point2d class, which means any color point2d object also has all of the properties of a point2d object. Okay. But there's a slight public-private catch to this structure. Okay, this is very important to kind of straighten out in your mind first, because this is usually the root of all frustration when dealing with inheritance. Okay, at this level anyway. Okay, so point2d is referred to as the base class, and color point2d is called the inherited or derived class. Okay, now second bullet point. Even though a color point2d object has all of the properties of a point2d object, including the x and it gets its own x and its own y. It gets its own point2d object with an x and a y. It cannot just access the x and y properties as if they were their own properties. Okay? Think about that for a moment. That's actually a good thing, because think about your fraction class. Let's say somebody wanted to extend your fraction class so that fractions could also have a color. But think about it, right? Now, would you want them to have access to the numerator and denominator properties directly? Probably not, right? Because then they might change a 1/2 into a 2/4. And then when you go to compare 2/4 to 1/2, you're going to get false. Okay? So you want to keep any class that's derived from that base class. You still don't want that class to have access directly to the private variables. Okay? So private variables are private no matter what. They are private just to the member functions of that class. Now, only member functions of the point2d class can access and modify the values of x and y, the private variables. But what can color point2d call? What can any function or which part of the class can everybody see? Public. All the member functions for point2d, like in our fraction class, are public. So those functions are freely available. But that's a good thing, because those functions ensure that our fraction is always in reduced form, that it's always in a valid state. So while you do have these properties of x and y, you can only get through them, or get to them, through the point2d public member functions. Okay? That's an important thing to realize. Also, the word public is very important in the public point2d inheritance section. Okay? If you exclude the word public, then point2d is actually considered to be what's called privately inherited, meaning you want to hide the fact to the outside world that you even have this internal point2d property. Okay? So when you publicly inherit from point2d, you can still call the point2d member functions in main. But when you leave out public, by default it's private, and then only the color point2d member functions can call point2d member functions. That's a lot to take in all at once. So let me demonstrate via code. Okay. Well, let me just check to see what's on the next slide first. For example, let me actually do the example. Okay, so, all right, here's all of our nice code, and I'm going to leave behind the fraction example, and we're going to create a new class called point2d with properties x and y. I'm going to create a default constructor which initializes x to 0, y to 0. Default constructor initializes. Okay. Let me not do it like this. Okay. Let me just declare a bunch of constructors, point2d, double input x, double input y, and let's just make a function called move. Move by x, move by y. Let's create a const function called print. That's just going to print out the points. And then let's make a setter and a getter, just so that we can, well, in general, you don't want to make setters and getters for all your variables. So let's shy away from that. When you need it, you can use it. But in general, the whole point of making variables x and y private is so that you can't just access the value directly. If you want to be able to access the variables directly, then you would make them public, and you wouldn't worry about this. Okay, so let's start with those. So here's how I would comment. So first of all, you need something like @class point2d, just name the class. @brief stores xy coordinates as doubles. And then here maybe we'll do like some examples. You would create a point by doing like point2d, p creates 0, 0, point2d, say p2, 3, 4, creates the point 3, 4. Okay? something like that. So this is a more, complicated write-up afterwards. All right, now in the class itself, right, you just write a few notes. So these are some constructors, right, because these are just the declarations. This is it's called a mutator function. Mutator moves the points, or let's say mutator transformation functions. So if we make other transformation functions like rotate or reflect or things like that, we'll just stick them in that right next there. And this is merely an accessor. Say accessors. OK, let's make these real quick. And I'll show you what we're going to do with our fraction stuff in a second. OK, so this is my default constructor. And we're going to field initialize this. Like so. That's all the lines of code there is. So this is the default constructor. Initializes point to 0, 0. Similarly here, we have this. And we're going to field initialize this as well. X with input x, y with input y. This one is a little bit longer, initializes point to input x, input at param input x. So you do at param, name of the variable, and then initial x coordinate. At param input y, initial y coordinate. OK, so I'm going to, this was just get this warmed up. OK, so now with these other ones, I'm just going to do this shorthand notation like that. We need a point 2D, colon, colon. What we're going to do is this is just going to do x plus equals move by x. This is going to be a y plus equals move by y. It's not declared const. It's a void, so we should put maybe a return statement there, but we don't have to. OK, and then we have the same thing with our print function. This one's easy because there's no input parameters or return parameters. So prints point period. OK, here we go. How do we want to print this? Well, let's just see out x. Well, let's just see out it like it's a coordinate. No return, no endl. OK. Again, if you leave out the point 2D colon colon, it has no idea what x and y are. Missing semicolon. OK, so there's my class point2D, very quickly created. Now if I create a class color point2D, inheriting publicly from point2D, this is now where the fun begins. So private is going to be a string color. Now, how do you construct a color point2D object? Well, you basically do the same thing as you would normally do, which is, OK, there's a default constructor. Maybe there's a constructor that takes maybe just a string. Maybe there's a color point2D which takes both the string and x and a y. Maybe there's a color point2D that initializes itself based on a point2D object. Okay, it grabs the values from a point2D object that already exists and creates a separate object from it. So maybe we would write a const point2D reference. OK, now how would we write all of these functions? OK, let's start with just a few of them. And OK, so we have all these point2Ds. Now, this is where things get a little more interesting. OK, so how do you initialize the x and y values? So let's think about this. Let me get rid of this, this, and this. OK. I want to initialize all of them by default. So wait, color Well, what's the default value of a string object? The empty string. Well, should I give it a color like white or blue, or should I leave it as the empty string? Let's make it white, okay? So let's give it a value so that by default, okay, we do that. How do we initialize x and y to 0? Let's try it. Okay, let's just try it. That's usually what you do in programming. You ask a question, and if no one's around to answer it, you just try it and see what happens. Okay, what happened? Well, x and y are what? Private to point2D. So I can't just access them directly. Okay? So let's, well, what happens if I don't specify? Okay, so how did they get initialized? Well, let's try and find out. Okay, so let's come to this code in main. And let's create like a point2D object, point2D p, point2D p2, 3, 4. Let's make a color point2D cp just by default. And now let's call p.print, p2.print. And now this is what's cool. cp dot, did I define a print function for color point2D? No. But because I'm inheriting from the point2D class, I have a point2D object kind of like inside me. Okay? That's what the color point2D has. So it can call a point2D member function as if it had that property itself, because it sort of does. It's containing a point2D object inside. So we can call the print function and have it just act on that point2D base class portion. Okay, so let's see what happens when we do this. Let me add in a bunch of return carriages. Okay, so what happened? What happened to the values of x and y in our color point2D object? They got initialized to 0. In other words, and this is what happens, the default constructor for point2D gets called. Okay? It constructs the properties of the color point2D corresponding to the point2D class by calling some constructor of the point2D class, because that's the only set of functions that can access those variables. Now here's a better question. Okay, so that default initializes it to 0, 0 with a color of white. Okay, now this is a simple one to code up. Color input color, so we can create a point with a certain color, like so. Okay, now how do we tell it to initialize the values of x and y? We can't access them directly, but we can call a constructor for them. Here's how you would do it. So, and this is kind of how you have to do it. Otherwise, we don't have any way to modify x and y. Well, we could call the move function if we wanted to. But here's how you would construct them. You would say, okay, well, first, input color. But we want our color to be input color. Then we want to construct the point2D part of ourself. Yeah? And we're going to call a particular constructor, and in fact, we're going to call the constructor that takes two parameters, the one with input x and input y. Let me split this up into multiple lines. Okay, so we're going to, again, the base class is point2D. Color point2D does not contain, as a member variable, a point2D object. It is a point2D object with an extra property. Okay, so we're not just initializing a point2D variable that's contained in the class. We are initializing a piece of the object itself. And so what we're doing is we're calling point2D on with the two parameters. And that's allowing us to specify the internal properties of that color point2D object. Similarly here, we do the same thing, which is, okay, we're going to initialize color using input color, and then we're going to create a point2D object using an already existing point object. Okay, so that's how you would construct a color point2D object in different ways. Let's see how we would do this in code. So color point2D. Now we have a bunch of different ways of initializing it. Let's initialize it using, say, blue, and then 5, 6. Oops, let's give it a name like cp2. And we'll call cp2.print. Let's create another one, color point2D, cp3 of, say, red. And then let's give it p2. Let's give it an already existing object. Okay? And now we do cp3.print, cout, and l. Okay? And as you can see, now we've gotten all of those properties. Okay, so that's how you construct an object, and you can specify exactly what you want the base class object to be constructed by. Okay. Now, like I said, cp3, if we try to call .x or y, those are private. Color, that's its own private variable. I can't access it outside. Okay? But move and print, these are perfectly valid functions. I can call them. But only, and this is what's going to happen to you sometime. At some point, you're going to write this code, and you're going to get the following, you're going to get an error. And the reason is because you're going to probably forget the use of the keyword public. Okay? Not accessible because, there we go. Here's how you prevent the color point2D object from accessing the base class member functions from calling them outside of or in main. Okay? So that's why you inherit publicly. It's so that you can call these functions like print as if they were your own functions. But as soon as you stop inheriting publicly, when you forget that or omit it, it's as if you're inheriting what's called privately. Okay? So public lets you do that. But regardless of whether you inherit publicly or privately, if you create your own print function, you can call any point2D base class member, either function, anything that's public in the point2D class inside the point2D member function. So let's make this const. I'll show you what I mean in a minute. Okay. So what I want to do is color point2D print. Now, do I want to copy and paste the print command from the point2D class? Did I hear it? How many would just copy and paste that? Or let's do this. How many people would write this? Cout, say color, and then x, y. How many people like this code? looks fine, right? Sort of. What did I do in this line of code? Does this line of code look familiar? Yeah, I took the point2d print function, and what did I do? I just counted the color in front. What did I tell you with fractions and with your polynomial assignment? If you ever find yourself duplicating code, what is that? Bad. Okay, it's not good. What if instead of this, what would be a better way to do it? So first of all, I'm going to see out color, and then what am I going to do? How about call the point2d print function? Okay, does that make sense? Okay. So I'm going to, that way if I change the format of how the points print out in the point2d class, that will get reflected in the color point2d class. Okay? If I copy and paste the code, if I make two separate versions of it, if anything changes, I have to maintain both copies. Okay? So this is the better way to do it. Now when I go to print out the points, something weird happens. What happened? How come all of a sudden I started printing out colors, whereas before they were just points? Okay, so see what I've done here? I have a base class called point2d, which has a print function. If color point2d has no print function, calling print will do what? Yeah, call the point2d print function. Now what did I do? What did I change? I added a function in the derived class by the exact same name. Okay. So what an object does, first and foremost, is it checks, do I have a function by this name? If it does, it calls that function. If it does not, then what does it do? Checks the base class. Okay? So if you don't want to customize the printing, don't define the print function in the derived class. Just let it call the point2d class. If you do want to customize it, though, you just give the function the same name in the derived class, and then to access the base class print, you just preface it with the name of the class, colon, colon, the name of the function. Okay? Here's a question. What happens if I try to write, what if I'm a little careless and I write this? What's going to happen? I got an infinite loop. Do I have any other? You got a warning. Good, these compilers good. Okay, so what is it doing and why is it doing this? Okay, stop. Okay. It's doing this because it's calling this function, it's printing out the color, and then it's calling itself again. It's saying, well, I'm a color point2d object, and it wants me to call the print function for the color point, do I have a color point2d print function? Yeah, so I call that one. And that's why it goes into the infinite loop. It keeps calling itself. Excuse me. That's why we have to terminate it by forcing it to say, no, 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 no. Call your base class version of the function. Okay? Okay, so that's, if you look at this code here, that's the summary of what the code I just wrote does. See, calling the base class functions, print. Okay, there's that. Unambiguous. Unambiguous. Okay. Now, here's an advanced topic. This is in your book. There's more than just public and private. Okay? There's public, there's private, and then there's protected. You know how you can't access x and y directly in the color point 2D class object? What if there was a way to say, unless you're a class derived from the point 2D class, think of me as private. But if you're going to be inheriting from the point 2D class, then you can access x and y directly. Okay? That's what protected does. Protected says, if you're trying to access x and y from, say, a color point 2D class, go ahead. You're inheriting from me. You have my properties. You have full permission to do whatever you want. But anything on the outside still cannot access them. Okay? So it gives permission to the derived class to treat variables x and y as if they were its own private member variables. Okay? Never use this. Okay? That's the suggestion a lot of people have. But it exists. Okay? It lets you otherwise access private variables if you're sure that any class derived from this knows what it's doing. Okay? But in general, your interface should allow you to not have to do that. Okay? Does that make sense? Yeah, so just look that over again if for more info. But pretty much all the code we're going to write and work with, we're never going to use protected. But it's a topic that exists, and you might see it in code at some point. So this is important. So under this design, so protected variables are just like private variables, only derived classes can access them directly. Okay? It's just like they're private member variables of the derived class itself. Okay? All right, so in particular, right, color point 2D member functions can access directly the variables x and y, and they don't have to go through the public member functions of point 2D. Okay. Any questions on class, inheritance, public, private? Good, good, good. We're almost there. There's one more thing I want to review because it is underlying most of the both conceptual and coding errors that occur later on in, say, Pic10C. Okay? So it's worth a review, and we're going to need to make sure we understand very intimately the difference between the various types of pointers there are in C++ and how to appropriately utilize them and handle memory associated with them. Okay? So this is important stuff. This is not just, oh, I learned this stuff at one point and I sort of get it. No, no, no. You have to really get it, okay, in order to save yourself a lot of trouble later on. Okay, so how many students did not ever use new and delete in 10A? Okay, so there's a few. I dislike new and delete at the early stage of instructing programming, and here's why. It's so easy to mess stuff up using new and delete. Okay? But here goes. Here's an explanation. Well, this is going to be a self-contained explanation of new and delete, so if you've never seen it before, don't worry about it. But everybody's seen what a pointer is. Okay? So, what is a pointer? A pointer literally just points to some location in memory. It could be a single object. It could be an array of objects. Okay? So if you look at here, you have int a equals 5. That's not a pointer. That's just a regular old int. Okay? Good enough. Double b of 3 with the square brackets, that creates an array. Now, b is a pointer type. Okay? B itself is a pointer. It points to 3 different values with indices 0, 1, and 2, but b is a pointer type. Okay? It refers to some location in memory. Now, new and delete are ways to access memory in a different location than what the double B line does. Okay, so there's two main different locations in memory when you're coding in C++. One is the stack and one is the heap. B of 3 creates these values on this stack, and using new, this heap array now points to variables that lie on this other location, a section of memory called the heap. Okay? But this is a pointer, B is a pointer. We're dealing with pointers, and the real difference here is precisely where they point to in memory and whether or not we have to sort of clean up after ourselves. In other words, if we create memory like double B of 3, do we need to acknowledge when we're done with it and clean up after ourselves? Okay, so let me just give you a brief rundown on the difference between stack and heap. This is a slide that I use in 10A towards the end, so it's probably, even if you took 10A with me, maybe you didn't fully quite get it. Basically, the stack is a small amount of memory. It's good for a few small variables, maybe pointers. You really want to just store a bunch of pointers on the stack. There's not a lot of memory here. But on the heap, yeah, there's a lot of memory on the heap. Okay? If you want to access or work with, say, huge data structures or a large matrix, for example, you want to work with that on the heap. Okay? It gives you a lot of flexibility, and it's a much larger pool of memory. Now, when you work with pointers, the idea is as follows. The idea is your pointer is on the stack, and it points to some set of memory on the heap. This is a standard paradigm, but you only get this stack-heap relationship when you see the keyword new being used. Okay? So let's just dissect what happens here. When you write int pointer A, you're creating a pointer variable on the stack. A is here. When you write new int of 5, new int of 5 allocates memory on the heap, exactly 5, room for 5 ints, and what it does is it returns the address to the first one. And because it's an array, arrays store their memory contiguously, one right after the other. So all you need is a pointer to the first element, and you know exactly where the other elements are. But that's why the code looks like the way it does. This calls some function which allocates some memory, and it just returns an address to the first one. Okay? So now A is on the stack, and A of 0, A of 1, A of 2, 3, 4, 5, those are all on the heap. When we call delete on A, why would you call delete? Well, you would call delete because anything you create on the heap has to be manually deleted. Okay? So every new needs a corresponding delete somewhere. But the important thing is there's a difference between A, which is the pointer, and the memory it points to. Okay? So if you're going to manually create this really nice flexible amount of memory, at some point you need to manually tell the processor, I'm done using it. That frees it up. And you still have the pointer A. A is still just some variable that exists, but it doesn't refer to any particularly reserved location in memory. I mean, it still has an address. It still refers to an address in memory, but it may not have anything to do with an int variable anymore. Yeah? This is a question is this how vectors work? Wait. Yeah, there we go. Okay. This is exactly how vectors work. But have you ever used new and delete with a vector? No. And don't start doing it. Please don't start using new and delete with vectors. Okay. Don't do it, don't do it, don't do it. Vector implements this automatically for you. Okay? So as far as you're aware of, you're just working with a variable v. And you are. V lies on the stack. Okay? But all of the elements that v of 0, v of 1, etc. refer to automatically refer to memory on the heap. They automatically get created on the heap, and they automatically get deallocated from the heap. Okay? You don't have to worry about manually doing anything with a vector. That's why vectors are awesome. Okay? You will not realize how awesome vectors are until you actually start managing memory yourself. Okay? So don't start using new and delete with vector. You don't need to do that. But if you create your own class that's supposed to be like a vector, that's basically what it's doing. Okay? And in fact, it's not just vector. How do you think a string works? Same thing. Now, name is not a pointer, right? Name is an object. But if it's a class object, what does it probably contain as a member? A pointer to some location in memory that contains the string of character, or that contains each character. Okay? So again, the idea is a pointer just contains an address somewhere. It's a very efficient data structure. You can store it in this small stack memory, and then it just points to things in this larger pool of memory. Okay? Okay. So here's a little warning. If you are going to use new and delete, after you delete memory, the pointer is still active. The pointer still has that address in memory, and it can still try and access the first element. Now, it might be garbage. It might give you an error. Did anyone on a Mac ever try it for your polynomial assignment, get like an error that had the word like thread in it? A runtime error? Yeah, okay, so, okay, at least one. On a Mac, for example, if you try and access outside the bounds of the array, you get this really cryptic error message. And what it's saying is, you went outside of what's reserved in memory. When you delete the memory and then you try and access it again, that's illegal because you don't have permission or a reserve on that memory. You can still try. I mean, in principle, it's a valid operation. But in terms of behavior, the behavior is not defined. It could crash. It could give you the value you're expecting. Your computer could explode. That's what it means to be undefined. Okay. So again, syntactically, you could try and print out the first element even after you've deleted it. There's actually no telling what this is going to do. Your computer could explode. It's not going to explode. But the point is that you cannot predict the behavior in all circumstances. And that's the key. It might work on your computer right now when you run it. It may not work tomorrow. It may not work when you update this one program or do whatever. It might not work on this other person's computer. But syntactically speaking, there's nothing wrong with trying to dereference a pointer. Okay, so I've just explained stack, heap. Stack is a little bit of memory. Heap is a large pool of memory. Okay? Now, when you write int a equals 5, double b equals 7, have we ever needed to clean up after ourselves? No. It's like I go into a room, I just throw everything around, and I come back and magically everything's all tidied up. Okay? It's kind of like what it was like when we were like 3, right? You go into a room, you play around, you mess stuff up, and then magically it all gets cleaned up. Okay? That's kind of what the stack does. Okay? The stack basically says any variables created on the stack, you just create them, don't worry about cleaning up, the processor handles them automatically for you. The heap memory, you have to manually clean up after yourself. So that's a little more dangerous memory. So it's very important to know, at least on the surface, what's created on the stack and what's created on the heap. So far, you never really needed to know any of this. And that's a beautiful thing. Okay? But now, as we get a more and more refined knowledge and more depth of knowledge and the functionality of what you can do in C++, it is important because this will underlie a lot of the errors that occur later on. Okay, so all of these variables here, every single value created using this code, every single one is on the stack. Okay? How do you know? There's no new or delete anywhere, and I'm not using vector or string. I'm only using fundamental types. Okay? Again, an array, by default, stores its elements on a stack. But if you have a new in there, that's when the array goes to the heap. Okay? But by default, everything is on the stack. And in particular, after main exits, once main finishes running, all of these variables are released. There's no memory leaks. Everything is well with the world. Okay? You don't have to clean up after yourself. excuse me. Again, if you write a function and you create a local variable inside that function, it's the same thing. Let's not worry about that for a second. Okay, now, if you create an array using new, then, now, this variable ARR lies on the stack because that one doesn't have anything new associated with it. That's just a variable. It's an integer pointer. Ignore everything to the right. But new integer array, or new int array, this creates memory on the heap and returns the address of the first element, and that's what the pointer gets set equal to. Okay? Okay. Okay, so here's something you might do. You might say, how large of an array would you like? You input a value. You then create an array of that size. It's going to be some garbage value. When you initialize an array, the value itself is not specified what it has to be. It's some random value, depending on what was there before you requested that location in memory. On Mac, it usually sets it equal to 0, but it doesn't have to. Usually on PC, it's some random value. But the point is I have a new without a delete. Okay? I am manually allocating memory on the heap, and so at some point I have to manually delete it. Now, I can't do it out after main ends, right? After main ends, the only way to access that value, that set of values, is through that ARR pointer. Okay? So I have to do it inside the... It's supposed to... Okay, do you see? The only thing that changed is delete. Okay? So I add in a delete. That deletes the array. Everything else is a stack variable. Everything gets taken care of. Okay? Everything else gets automatically reclaimed by the processor. Okay. Let's end with this slide, and we'll pick up on this slide next time, which is, okay, do yourselves a favor and look at this slide very carefully before you come to class on Monday. Okay? So let me just briefly point out, there's several sections to it. Create a fraction A of 1, 2. Create a fraction pointer. All types come with a free pointer type for free. Okay? If you create a class called point2d or fraction, you can create a fraction pointer or a color point2d pointer. Okay? As long as you've created the class, you get the pointer version for free. What do you give a pointer? You give a pointer the address of an object, and then you can access the object either through the object itself, A, or through the pointer. And you can also create objects on the heap as well. Okay? You just have to manually delete them. And what we're going to do now is we're going to look at this part here, which is we need to be very keenly aware of what deletes what and why, and do we even need to delete stuff. Okay, so we'll go over next time. We'll finish up this just review of pointers, just to make sure everyone's kind of on the same page, and then we'll go into polymorphism.